All right, so we have Carl today. Hi,
Yes,
Carl.
he's
How are
on.
you?
I'm good. How are you?
I'm good too. All right, welcome to the second session of data modeling. Uh, so yesterday we tried to understand what is a data model, why do we need a data model, and who does the data modeling. Okay. Now today let us proceed a little further. Let us try to understand how do we make a data model. We try to also understand a little bit about logical model. What are the different kinds of models that we make in the data modeling world? So we have something called conceptual model, then we have a logical model, we have physical model, and there was a high level discussion on what exactly each of those are. So now let us proceed further that what happens when we try to make a data model? How do we make a data model? So like we discussed, the very first thing that a modeler gets when he has to make a model is the BRD document. That is a business requirement document. Now from that business requirement document, he has to extract the pieces of information where he finds the things are represented in form of entities. So let's say I have just a few lines, let's say I have a paragraph with a few lines. It says there is a company, and a company has a lot of employees working in a building, um, and it has a lot of departments. Now each of those employees are working in one or the other departments. So I've just now tried to put three lines of statement here. Okay. Uh,
Mhm.
what do we want to do? We want to make a data model out of it. So this three lines of text is my requirement, and out of this now I will have to identify the set of entities. What should be my set of entities and what should be the relationship between them? So now how to do that? How do we identify an entity basically? Entity is identified with the by just imagining it as some kind of an object or a noun. Now for example, if I'm talking about employees in a company, what are the employees? It's a group of people who are working in a company. So my one of the entities will be employees working. Okay. And these employees are working in a department. Again, now what is a department? There are of course multiple departments in a company. So what I will do, I will
Mhm.
simply figure out, I will say there is another entity called as department, and then I will try to make some kind of a relationship between them. That what kind of relationship we will make, that we will come to. There are different kinds of relationships in an entity relationship diagram. So first, in a conceptual model, we just try to make a set of entities and we try to name those entities on a very high level. Let me just try to, I don't really put off the pen completely here.
Vipul, can you make it full screen?
Sure, but then I will not be able to draw, I think so. Uh,
Click F5 or you can
no,
simply
yeah,
remove this.
I'll do that, but
Okay, okay.
I'll
Okay,
not
okay, you may
be,
proceed.
yeah, I want to draw it as well, so I'll not be able to use a text box then.
Okay, okay, no issues. You may continue.
Yeah. Okay, so we have something called as employee. We have something called as a department. Now, once I identify the entities, I try to put certain kind of details in my conceptual model. So what are those details? If I'm talking about an employee has to be identified with something. Okay, now this identification to any entity is given with something called as primary key, an identifier, something which is going to uniquely identify every employee in a company. And what could be that
Okay.
primary key? Now, we can imagine usually in every company there is an employee ID given to every employee. So we are going to put here employee ID as one of the attributes of this entity. Similarly, the department, now there are set of, let's say, 5 departments in a company. So I will have to identify each of those departments with some unique identifier.
So like a department ID or
Absolutely right.
department name.
Department, either department ID or we can call it a department number. Department name is something we should try to avoid because department name can still be repeating. Let's say
Okay.
I have 2 different buildings of the same company and the same department is in both the buildings. Okay, so something
Now
which is going
PK
to
is
be,
private key.
sorry, yeah, PK is primary key, that's right. Okay,
Primary key or private key?
primary key,
Okay.
primary, yeah. And this is also going to be the primary key of this entity. Now, once you have identified the entities and you have identified the unique identifiers of those entities, after that we try to make a relationship between them. So what kind of relationship we have to make? That is something now we have to look at what the business is talking about. Now here, when I try to state the requirement in just 3 lines, I said there is a company which has a set of employees, and there are a set of departments, and the employees are working in those departments. So what sort of relationships are we talking about? There are 3 kinds of relationships when we talk about entity relationship diagram. There is something called as one-to-one relationship, then there is something called as one-to-many relationship, and there is something called as many-to-many relationship. Now here, in a very simple terms, what we are going to say, we will say that employee is working in one or more departments. What does it mean?
One to many.
It's one-to-many, simple. If, let's say, if it had been the case that one employee is working in just one department, let's say,
One to one.
yeah, so if, let's say, Carl works in a HR department, he cannot work in any other department, then it will be what sort of relationship?
One to one.
It's a one-to-one relationship. And the reverse can also be true, of course, which is always the case that one department has multiple employees. So when that is a relationship formed from both the sides, that is, one employee is working in more than one department, and every department has one or more employees. That is when we say there is a many-to-many relationship formed. Okay, so this is, I mean, simply how we represent. This is
And
just a simple
then
example.
basically, we do this like data modeling in power designer, basically.
Yes, that's right.
We set the relationship. Okay.
Yeah, yeah. We will use that. We will come to Power Designer. Maybe we'll start from tomorrow or something. So I'm just trying to currently, explain here with the
Okay.
basic
Yeah.
concept. So, okay, so this is the concept of entity and the relationship. A very simple, basic example. Now, let's try to explain it a little more. Uh, so we have made an entity, we have made an attribute in it, we have put a primary key, and we have just defined a basic relationship. Let me just try to make it more elaborate. So, okay, we are talking here as one to many. So department has one or more employees. Now, what is this employee ID? This is like we discussed. It's a primary key of the entity employee.
So a unique value for every tuple.
Every tuple, that's correct. And now there would be a set of attributes for this entity. Employee ID is also an attribute, and then there will be set of many other attributes. What can be other attributes? Something which will give more information about that entity. So can you try to
Gender,
imagine?
name.
Yeah, that's right. So employee name, let's say, gender, it could be employee address, anything which is actually trying to explain more about this entity.
Okay.
And it could be any set of attributes, I mean, any number of attributes. It's like it could be as long as even 200 attributes, 300 attributes. It really depends. It's usually not that long, but sometimes in the companies, there are really so big entities where, there are a lot of attributes. In that case, it is always better to break the entity into two parts. We will discuss about that also in the later lectures. Okay,
Okay.
so same is the case for department. So we have department ID, and like we were saying, there has to be something called department name. Now, name is a text field which can repeat, so it's not a primary key. Then what else can be there? Department location maybe. Okay. Now, so we have made an entity. We have tried to define the unique identifier of the entity, and we have put certain set of attributes, and also we have put a relationship in that. So then what do we do next? We try to further elaborate. Now, more we try to elaborate, the more we are talking in the terms of a logical model. And that is the difference between a conceptual model and the logical model. In the
So the
conceptual
more
model,
detail you get,
yeah,
you have more concepts. The more detailed it is.
exactly. So till here, whatever we have made, this, simply let's say the set of two boxes, one box is about employee, the other is about department, making a relationship between them, putting a primary key, and defining just a set of 2 to 3 basic major attributes. Even if we don't define these attributes, let's say I don't put here employee name, gender, and employee address, even then it is okay to keep it as part of conceptual model. But yes, just for a little more clarity, I can put a set of basic attributes, what that is name, gender, and employee address, and leave out rest of the attributes. Same is the case of department. I can put just 2 to 3 attributes, and that's it. Now this whole part can be treated as a conceptual model. When it is going to be converted into a logical model, that is when we will try to define more about each of these two entities. Then we will not only just say TK here, but we also have to define that what is exactly the data type here. Let's say it's a number.
So like an integer or
Exactly.
string.
Right. Yes. Yes. That's what we have to define here. Same is the case for employee name. We will have to define what data type it is. in the tool that is in the Power Designer or in the Erwin, you can always do
Hmm.
these definition of data types can also be done in conceptual model, but it is better to do in logical model. Tool always gives us freedom to do whatever we want to in the conceptual model, because from the modeling perspective, there is no such kind of a bar put by the company which sells the tool, where it says that what you should make in conceptual and what you should not. Many companies, they
Okay.
want to put everything in the conceptual model, whereas other companies, you will find they will put some very basic details and rest of the things they want to put in the logical model. So it depends. It's never, but yeah, it's a good practice. Usually, the standard practice is to keep as less detail as possible in conceptual and rest in the logical part. Okay, so this kind of, detailing when we do, then we talk about the logical model. Okay, now after this, we have made the basic structure. We have also put a relationship here. I mean, it's right now it's just in a form of a line. And when we are going to make it in a tool, it will be much more clear because the notations are different over there. Uh,
Hmm.
then what we should also know is a concept of foreign key. Do you have any idea about this, Carl, already?
The what kind of key?
Foreign key.
No.
Okay. So, what is a foreign key? Basically, it's just like we talked about primary key. Now, when this relationship is formed between these two entities, here the relationship I have made is one to many, which is, if you try to read out the relationship, it says one department can have multiple employees. Am I right?
Hmm.
Uh, uh, just try to imagine that on this side where exactly the arrow is, you can see. So that is the many side. Many means there is a
Branching. Yeah. Okay.
yeah. So now when actually we are going to store this in the database in form of tables, let's say. So you have you seen around something around Oracle database or uh, any kind of tables or something? If you ever got
Yeah.
a
Yeah.
chance. Okay, you have some idea. Okay, so there we store the information in form of tables. Basically, each of the entities when we are going to implement in the database, because that is our the how you call the aim, the purpose of making a data model is actually to convert it into tables in relational tables for some database, be it
Yeah. Relational
Oracle.
models. Yeah.
Yeah. So when we do that, then how those tables will get related to each other? They will get connected to each other with the help of something called as foreign key. Okay, so here we have made simply a relationship where we are saying department has one or more employees, but as soon as I convert this logical model into a physical model, then there will be two tables, one table called as employee and the another table called as department, that will be created in a database, and a foreign key will be created from department table to the employee table. So inside the employee table, I will have additional attribute by the name department ID that will come as a foreign key from the table department. Now this particular column, because in database when we talk, then attribute is actually termed as a column. So this column of a table will be referring to this particular column, which is a primary key of this particular table.
Okay.
Okay, let's try to understand more. I'll try to open here in Excel sheet. So let's try to put some data in it so it will be more clear.
Now, what's the purpose of the foreign key?
Yeah, let's try to understand that. All right, so I have one table here called as department. So what all columns did I make here? Firstly, department ID, then department name, and department location, let's say. Only three columns I have. Let's try to put some data in this table. I have, let's say, three departments in my company. One is HR department, another is IT department, third is, let's say, accounts department, and the location is, let's say, this is in building 1. Second is also in building 1. This is in building 2 maybe.
Okay.
And I have a set of certain employees working. What else we had? Employee address, right? And maybe gender. So let's put some employee ID. Don't worry about this E1, E2. I mean, it's going to be always a numeric data. The very first column, the primary key is always chosen as a numeric column.
Okay.
I'm just putting it here for only for the clarity, so that because if I put here 1, 2, 3, this might create a confusion because here also it's 1, 2, 3. So I have put it as E1, E2. Okay. Now let's put some names. Okay, and we put some address. I'm just going to put country name maybe for now. And okay. Now I want to say that first two employees, Carl and Vipul, works in department 1. Okay, how should I say this? Because now this when I made this diagram, I simply said that a department has multiple employees. So one particular department, let's say HR, I have set of three departments. I have set of four employees, and I want to make a relationship between them. I say that HR department has multiple employees. That is, it has Carl working in it, it has Vipul working in it, it has Hitendra working in it. Three employees are working in that department. So to do it in my database, when I make these tables, department and employee, the table on the many side, the one which has one to many relationship, on the many table, I'm going to make a foreign key, which will refer to the primary key of this table, of the first table. So department
Okay.
ID. Here in this table, department table is a primary key, correct? Here we made it as a primary key if you see PK. But the same thing when it comes here, this column, department ID will become a foreign key. So in the foreign key, what we will put? We will just put the value of this particular row, where I say department ID 1. So for second row,
So,
yeah, tell me.
so it's kind of like a link to another entity, basically.
Exactly. That's a kind of a link. It is going to link these two entities in such a way that every row of this particular table will get linked to some row of this table.
Okay.
Okay. So and the I mean here we have to see what sort of relationship it is. If it's a one-to-many relationship, then we will just put here it can be the same department has multiple employees. So the first employee is working in department 1, second employee E2 is also working in department 1, third employee is working in department 1. So in short, by looking at this table, this particular table it's alone, we can say that one department, that is department number 1, has multiple employees, three employees working in it. And if I read it from the reverse, I can say many employees, that is multiple employees, 3 employees are working in one particular department. The fourth employee can work in another department, maybe.
And that would be considered one to one, correct?
So yeah, this is considered one to one. Now, when we make a relationship, the relationship is always made between the entities. Okay, when we here now, because I have put only 4 employees, and now the fourth employee is working in department 2. If I had here fifth employee and some XYZ name in some country, now I'm free to put here the department 2. Okay, now it's not one to one anymore. So one to one relationship cannot be said only for one particular row of a table. Not it cannot be really defined for one table for of an entity. It has to be for that
The
complete
whole
entity. Yes,
whole so it has to be based on the whole employee.
exactly. So which means now even if I don't have this row here E5, if this row is not existing, I have the data up till E4 only, and I'm saying that E4 is working in department 2. Still, the relationship between employee and department will remain one to many. One department will have multiple employees. Why is that so?
Okay.
Because any time in future, I'm free to put the data in the department 2. I'm free to say that there is an additional employee E5 who also works in department 2. Okay, if I try
Okay.
to put some kind of a restriction here, if I say that, let's say I make some kind of a unique key on this particular table column, department ID. We'll talk about this, what is a unique key. So in that case, I will not be able to put the same data. I can't, if I put here 1, I can't put 1 again here. I have to put 2, I have to put 3 here. So then 4, 5. So then in that case, it will become a one-to-one relationship. We'll talk about how do we implement one-to-one.
Okay.
Okay, so this is the concept of the foreign keys. So we have spoken about the unique identifier. Now, primary key. We have spoken about the foreign key, and the unique key also. So unique in the unique key in the last one that we just now spoke. All we do is inside the database when we try to create these tables. The primary key basically in any relational database uh, we have to define. So when I fire the SQL statement, I put the DDL. I say create table department where and then I put the column names over there. After that, I have to put the primary key that what exactly which column of that particular table will act as a primary key. As soon as I put that, then database will not allow me to repeat the data of that column.
That's unique.
It's going to be
So
unique,
each tuple has to have unique.
right?
Okay.
And not only unique, it will be not null. It has to be a mandatory value. I can't leave it null over here. Null means no value, so I can't leave
Yes.
the yeah. Same is the case for the another entity also. But in case of there is another concept of unique key. It's also in the model it is referred to as UK. So let's say if I had employee ID, uh, department or something, and then I have something called as mobile number. Now mobile number is always unique for every person.
Okay.
So I'm going to put a constraint on this column in the relational database such that it will again not allow me to repeat the data. The data will always be different, but then I will have the liberty to leave it nullable for any one of the tuples,
Okay.
unless I make this particular column as mandatory column. Now we will talk again about this optionality and what which columns have to be made mandatory, which columns can be left nullable. So there is a very thin line difference between a primary key and a mandatory unique key. A mandatory unique key column also acts as a primary key, but the primary key is the column which is going to, which the database through which the link is formed between the two tables. Here, department ID is a primary key, and in this entity, employee ID is a primary key. And because we wanted to form a link between department and employee, we brought department ID as a foreign key in this table, employee.
So
Yeah.
so primary keys are like a unique identifier, but it's a higher tier than a
Right.
what's the mobile one called again?
So it's the difference between the unique key and the primary key is only that primary key is something which is uniquely identifying. It is a not nullable key, and it is one of the primary identifiers of that
Yeah.
table. Okay.
Yeah, I understand. So there's less importance to the unique key than the primary key. The primary key
exactly
describes it basically, whereas the unique key just sets a restriction so it doesn't allow others to copy that have the same value.
Exactly, that's a basic difference. That's a basic difference, and not only that, also primary key will always be one in a particular table. So here, if I say department ID is a primary key, then I cannot make another primary key as department name. No, that's not possible. But
Okay.
if I am talking about unique key, I can make any number of columns as a unique key. So if I have made mobile number, I can have another column here, let's say SSN code or something. And then I can have another column here. So each of the columns can be made individually a unique key.
Okay. So but you can only have one primary key.
But only one primary key, that's right. Okay, so that's how we try to define the different relationship between the entities, and here we have made a one-to-many relationship. Now, had this been the case of one-to-one relationship, in that case, what we are going to do? Can you imagine that? Can you try to think what we'll have to do if we are going to make a one-to-one between department and employee?
Regarding what?
So let's say I'm saying that one employee works in one particular department. Even Carl works in HR department. Vipul works in IT department. Hitendra works in accounts department. So every department has only one employee working in it. Now, when I'm going to implement this, what sort of changes I should do here in this table?
They're all going to have separate unique. You're going to make that unique as well.
Yes, that's it. That's all I'm going to do. So department ID is going to be a unique ID, so that this number does not repeat here. Now here I'm going to put 1, and I say Vipul works in HR. There's 3. Similarly, now we don't have more than 3 departments, so we should have 4th department and the 5th department, and that's what I'm going to put here, 4 and 5. Okay, so that's how we make a one-to-one relationship. When we try to implement in the database, on the other side, that particular column is going to be on the ones the unique column. It cannot have a repeated values. Okay, it's everything is clear till here. Anything you want to ask? Any question?
No, I understand.
Okay, nice. All right. Now let's take another small example then. I'll just read out, a statement, and you have to let me know what all are the entities that I should make out of it, and what should be the attributes among them. Okay. So let's say there is a hotel. Okay, and hotel has rooms in it. And now customers, they come and stay in a hotel. Uh, Now the rooms, they have a checkout time. There's a fixed checkout time at the time at which the customer checks out. And the rooms that in the particular building of a hotel, they are on different floors. So there's a first floor, second floor, third floor. Okay, now out of these 3 to 4 statements, what do you think should be the different entities, and what should be
The
the
rooms and the customers.
okay, let's just try to make here. Uh, I have an entity called as a room, you are saying, and I should have another entity called as customers. Okay,
Correct.
and then what? Let's okay, so 2 entities I can make. That's right. And then what all should be the different attributes? Just the basic. Let's talk. I mean,
Um,
let's imagine we are making a conceptual model. We are not making logical right now. So in logic, conceptual model,
um,
what all I should put?
room IDs and customer IDs as primary keys.
Uh-huh. So I have another text box here, and I say, what's this? Room ID. So that's gonna be my primary key. Perfect. And I should have similarly something called customer ID. What else? Anything I should put in a conceptual model?
Uh, Maybe type of room,
Yeah, okay.
like big, small,
Yeah,
and then
size of room.
checkout time. Yeah, size of room.
Yeah, that's right. And then the checkout time. Okay, perfect. So this is the attribute because when we go through the any requirement, uh, even if that particular attribute, it looks to be an obvious one, we still should try to put it in at least the conceptual model. Now we will talk about
Hmm.
this later, that why we should not put the checkout time, or if there is any possibility that we can try to leave these attributes and put rest of the attributes. Although in the requirement it clearly says that every room has a checkout time, but why we can just leave it and not put it, because we are sure that every room has the same checkout time.
Oh, okay.
Yeah, so if let's say if there has been the case that every room has different checkout times, or a set of rooms have this, let's say 5 rooms have same checkout time and rest 5 are different, then it would still make some sense to put the checkout time attribute. But if everything is same, then we don't have to unnecessarily, populate our database. We don't have to
Because
increase
that would
its
just
size.
add more data that
Right.
we might not need.
Yes. Okay. So that's what when we make a logical model, that's when we will try to talk more about this. So customer, what do you think? What more attributes I can put here?
Uh, Name,
I can put customer name. Okay. And then
um, maybe I don't know how they're paying,
yeah, that can be.
um,
So let's put the
or
address. Maybe
address or
yeah,
phone number.
phone number can be there. That's right. Phone number here, and then like you said, we can have something called payment methods. How they are paying. All of this can be the different attributes. Now, once we make a set of basic attributes, then we try to form a relationship. What sort of relationship should we make between room and customer?
Um.
Okay, before we make the relationship, also there was the third thing that that I just stated, that the rooms are on different floors. How do you think
Oh,
should we
okay.
capture that? Should I make the
Kind of
floor?
like
Yeah,
how like you had multiple rooms per, or no, multiple floors per customer,
multiple
or
floors per customer.
or
Uh,
um
Try to think more.
multiple customers per floor.
Multiple customers
So
per
stay,
floor. That's right. So customers, there will be set of many. So many customers will be staying on one each floor. But
yep.
where they will be staying, they will be staying inside a room. Am I right?
Mm-hmm.
And the room is it's on a particular floor.
Yep.
So in short, what we are trying to say here, that we have another entity
One. Yeah.
that's called as floor. There's an entity called as floor, and that entity has a relationship with the room entity. Why do you think we should make a relationship between floor entity and the room entity, and why not between floor and the customer? Try to imagine something, whatever comes to your mind.
So you're saying we should relate the floor to the room, but not the floor to the customer,
Yeah, that's right.
because the floor has no relationship to the customer, because the floor refers to what, or no, the room refers to what floor
What
the
floor it is
it's
upon.
located in,
That's right. That's
but
right.
it has no connection toward the customer.
Right. So that's how we actually, what looks to us something which can be made, we have to try to find out the correct relationship. Although we can say that customers are related to a floor because customers will be staying on the floor, but the customers are not permanent. The customers are there on the floor and they will leave after a few days. And then what's the relationship between that particular customer and the floor? There is no relationship because customer has already left the
No
hotel.
more.
So so we have to find a permanent relationship always between the entities. Here the permanent relationship holds between the floor and the room. So floor number is there, and floor will be now inside one building. So we can say the building number. I don't know what's
Okay,
wrong here.
that makes sense.
Right. So that's how it's we will define the relationship. And what's the relationship between customer and the room? What sort of relationship we should make?
Uh, what, like
Which
maybe
should be
one
the
to
one
one?
relationship and which should be the many side?
Uh, the customers have one or many to one with the room.
Many to one
Maybe,
with
oh
the
no,
room. Hmm.
they don't have multiple rooms though.
Right. So which side
It's
should be one and which side should be many?
the room should be one, and then the customer should be many.
Right. That's correct. So one room has multiple customers. In simple to say that. And
And
this,
then same
yeah,
with the floor.
same with the floor.
I guess you could say there's many rooms to one floor.
Many rooms to one floor. That's right. So we can simply draw here. One room has multiple customers. So the arrow side is the multiple side, and same is the case here. One floor can have multiple rooms. Okay. This is a simple now model that we try to make with just three lines of statement. Now, why I try to take this example? Just to give a feeling about how we actually identify the entities and try to make a model out of it. Now, this three lines of statements could be 30 pages of a document. It could be 100
Mm-hmm.
pages of a BRD, that is business requirement document, where you will find a lot of details written about a particular project. Usually, it's not that obvious or something that you can easily imagine. When you work in a software company for any project or for any client, the very first thing that you try to see is that you are working for under which domain. Let's say you are working for a retail industry. Then the very first thing in a BRD document, or even if you don't have a BRD document, if, within the initial requirement gathering meetings, uh, the industry knowledge is gathered. That what that industry is doing. If it's a retail industry, what are the different processes involved? If we talk about the retail, what they do, they try to sell the products to the customers from the
Mm-hmm.
stores. So if it's, let's say it's a Walmart or any other, I mean any retail chain. So each of them is selling the products. Of course, when they are selling, they are buying those products from some vendors, some manufacturers. Okay, and then they are storing these products in some warehouse in the inventory. So there's a whole set of supply chain management. This kind of overall functional process has to be understood before we actually even start making a simple model. Once the overall high level functional design is clear, that's when we try to drill down and focus upon one particular process, because data model in the end is not going to be about the whole end-to-end process. It's going to be about one particular process. Let's say if we talk about that same retail chain, then the data model might be about a software application that is being used for purchase of the articles from the vendors. Okay,
Mm-hmm.
or it could be about let's say the selling of the articles to the customers. It could be about an e-commerce application like Amazon or eBay. Let's say if Walmart had been doing the e-commerce thing, or any other company they are doing. So they are selling. So then it will come under the sales process. So first we understand the higher big umbrella about the big business that industry is doing, and then we try to drill down to the smaller process in it. Or in the functional terms, it's also called as the domains and building blocks. The whole set big business is broken down into several domains, and each domain has multiple building blocks in it. Now here, what could be the different domains in the retail industry? One domain can be the sales domain. Another domain is a purchase domain. Purchase means the company is purchasing articles from the manufacturers. The third could be the logistics, where they're storing or they're moving the goods between the warehouses or warehouses to the stores. And then each of the domain, if we further now try to identify, the sales domain can have multiple building blocks. One building block can be your e-commerce site, the channel through which the selling is happening. The another could be POS, the
Mm-hmm.
point of sale, which is actually the store,
Point of sales.
through where the selling is happening. So all of that will come under the building blocks. Okay, so inside that building block, then we make a model for that software application.
Okay.
So I hope things were clear today.
Yeah, they
We'll
were.
try to continue more tomorrow. We will talk, now in more detail of these entities. Tomorrow we will start working on Power Designer, and uh, what sort of relationships. Now we have already talked about it. Three different kinds of relationships we try to understand: one to one, one to many, and many to many. So how do we, what are the different notations in the tool, and what are the concepts of cardinality, optionality, and then dependency? All of those things we will start discussing from tomorrow onwards.
Okay. And I'm currently taking a SQL class, so I kind of understand like the relationship between data modeling in SQL or just any query languages. We set up the data here, and then SQL allows us to pull the data or even reorganize the data, correct? Or like I'm
Yeah,
trying to.
that's right. So let's say if this was the two different tables that we made inside the database. One is department, another is employee. Okay.
Mm-hmm.
Now, when I have made these tables in an Excel sheet and I have put here the data, exactly what data I have put in these two tables. When I'm trying to do this exercise of putting the data inside the tables, I'm talking about the physical model, or let's call it the exactly I'm talking about is the database. It could be Oracle, it could be Teradata, or it could be anything. And now when I
Mm-hmm.
have to fetch the data, because here in form of Excel sheet, I can just see these 5 rows. It's easier. It's simple that only 5 rows are there. And now let's imagine there are 1 million rows in this particular table employee. Okay. And I
Mm-hmm.
want to find out all those employees who are living
That
in
live in
India,
US
live in US maybe.
or
Yeah.
India.
Yeah.
Okay.
So I can't just keep on browsing through the Excel sheet, doing this up and down here and try to then put a filter or something, right? That will
Mm-hmm.
be too much of a effort and time consuming and so instead of that I will be having a tool means a kind of something which can help me do the job quickly and some so that language which the database understands, and that language is called as SQL, server
Okay.
query language, which actually the database is where we are going to say to the database that please find out from this table employee all those employees who are living in US, and it will quickly fetch all of those employees and throw it to us on the
And you can
screen.
further like limit your details to multiple details. Say, return the IDs of people who fit this relation. Say are older than 3 or haven't live in a specific state or something like that. Correct.
Exactly what you're saying is absolutely right. So whatever filters we want to put, something that we can do here in the Excel sheet also by just putting here this something we have here, the filter. uh,
Mm-hmm.
So this kind of filtering I can do, and I can select that particular values. The same thing I
Mm-hmm.
do it with the help of SQL also. But then why I
Okay.
use a SQL in the database? Because that is the language that database understands, and uh, the database can hold much
More.
more data than a simple file system, than an Excel sheet or any text file.
And then, so whenever you do a query, it'll return another query, so you can use that on top of your data, correct?
Yes, that's right. So
Okay.
there is. I mean, when you learn the SQL, it's as you proceed. I mean, there is once some basic SQL, then there is intermediate, then there is advanced SQL, where you have these nested queries, the query inside a query, the subquery concept. So whatever data is returned, let's say if something has been returned by a particular query, these 3 rows are returned. Now, out of these 3 rows, I
Mm-hmm.
want to perform more operations.
Another.
Yeah.
Yep.
So all those things. What we can do is, let's say once we finish this, we reach up to the stage of logical model, then we can have 1 or 2 sessions on the SQL. Okay, so things will be more clear because before I proceed to the physical model, it will be good to have an idea about how the SQL is going to work.
Yeah,
Okay, so
I'm
yeah,
currently taking a class, so I'm trying to at the same time. So I'm trying to
oh, you're taking a class. Okay,
combine.
sure.
Yeah. So
So that'll be good, I think. Then it's fine. So anything that you want to discuss anytime with SQL, just let me know. And
okay.